Okay, to solve this one, the first one we need to add. So we're going to add x plus 6 plus x2 plus 9. At the end, it will give us x2 plus x, and 6 plus 9 is 11. So that's the answer. Now, we're going to do the same thing over here, but subtracting. So it will be minus x2 plus x minus 3. That's the answer.
So next we are going to do the c, which is fx multiplied by gx. So first we're gonna substitute it. It will be x plus 6 multiplied by x squared plus 9. X times x squared is x cubed. X times 9 is 9x plus 6 times x squared, 6x squared, and then is 6 times 9, which is 54. So now it's pretty easy, this one. We just need to put it, or well, write it in the right way, which it will be x cubed first plus the 6 square plus 9x plus 54. And well, this one will be the last answer. Okay, so now we are going to do the d, which is gx divided by fx. And if we just pass it like to another easiest way, it will just be gx and below fx. So if we substitute it, it will be x squared plus 0x plus 9. We add the 0x because, well, it's necessary to do the operation. And then it will be divided by x plus 6. Now, to see by which we're going to divide it, here we have the x plus 6, and we just pass the 6 to the other side, which it will be x minus 6. Now for this one, we're going to use that synthetic division because it's easier for me, yeah. So there's just one x squared, so we just pass the 1. There's 0x, so the 0 stays that way, and we just pass the 9. And here I will put the minus 6 to remember like where we're going to use. The 1 just passes, and then it will be 1 times minus 6, and it is minus 6, and well, it just passes that way because we don't need to zoom or to add or take away anything because it's a 0 here. So minus 6 times minus 6 is positive 36, and here we just add it, and it is 45. So we just write it down, and the answer to this, it will be x minus 6, and the 45 is our remainder. And that is the final answer. Now we're going to do the e, which is basically f, then the gx inside the parentheses. And in here, the gx takes the places of the x. You will see. We substituted and we put x squared plus 9 plus 6, because how I told you, the dx takes the place of the x, so that's why we write x squared plus 9 instead of the x. So now we basically need to do the operation, and we just need to add the 9 and the 6, which will give us 15. So this is the final answer. It's pretty simple. Now let's do the f, which is basically the e, but instead of the gx being like inside of the fx is the fx inside of the gx. So yeah, we write down x plus 6 squared plus 9. Let's first do the x plus 6 squared and x times x is x squared and x times 6 is 6x. Now 6 times x, 6x, and 6 times 6 is 36. And well, now we just add the 6x and the other 6x, and it will be 12x. And now we add the 9 here, and we will get our final answer, which is x squared plus 12x plus 45. Now we're going to do the g, which is g fx divided by fx. Here, the fx can get cancelled between each other, so yeah. And for not doing a lot of operations, we can just take the answer of the f, which is x squared plus 12x plus 45. So we write this down, x squared plus 45 divided by x plus 6. Now we're also going to use the synthetic division, and again we just pass the 6 to the other side, which is x equals minus 6. We pass the 1 of the x squared, the 12 of the x, and the 45, and write the minus 6 here. So we can do the multiplications and all that. We pass the 1 just by, yeah, we just pass it. And we multiply 1 times negative 6, and it'll just be like negative 6. Now 12 minus 6 is 6. We multiply 6 times negative 6, and it is negative 36, and as a result it is 9. So the final result of all these is x plus 6, and as a reminder, we got the 9. And that's the final answer.
Today we're going to see how to take the domain and range of these two examples. So first we need to know that when asked D and R, the D is the domain and R is the range. First, the domain is going to be the first number of every of these letters. For example, it's 7, minus 3, 0, 9, and 7. So it's always the first number. And in this one, it's the same. 0, minus 2, 8, minus 9, and 4. Now, the range is always the second number. So in this one, it will obviously be 8, 5, 1, 5, and 2. And in this one, it's the same. It will be minus 1, minus 2, 0, minus 8, and minus 7. First, we need to know that a function is always touching one point. So we're going to see if these two examples are a function or they are. First one, it's this one. We can see that it's clearly a function because it's touching this point, and this one, it's touching this point and this point. So yes, this is a function. Now, this one, we know that it isn't clearly touching any point in particular, so this one isn't a function.
Now we are going to determine the domain and range of an algebraic function. This one is a linear function, and thus the domain and the range will always be infinite. So yeah, here we don't have to do any operation. First, we put the negative infinite and then the positive infinite. Now to graphic, well, here in like the graphic, first we need to take out like the, the first dot. And well, in that one, the x is gonna be equal to 0. So, well, yeah, it will be f and then 0, that is equal to 8. And as the x is equal to 0, again, we just write the 0 minus 7, and 8 times 0 is equal 0. So the answer is 7, and that will be the first dot. Yeah, the 7 is equals to y, yeah. Now we need to take out the second dot, and the one fx is equal to 0. Then it will be 8x minus 7 is equal to 0, and we just start like to simplifying the equation. It will be 8x minus 7 because the 7 passes to the other side, and as here is negative, it changes to positive. Now x is equal to 7 divided by 8, which is 0.87. So the second dot will be 0.87, and 0 is y. So now we just need to put the dots on the graphic. First we find the first dot, which is x is 0, and then y is negative 7 to here is the first dot. And the second one is x 0.87, I think like here, and as y is 0, we just put it here. And now we just put the line. Yeah, something like that. And yeah, this will be all. Okay, now we're going to also determine the domain and range of an algebraic function, but this time with a quadratic function. Yeah, well, the domain will also be infinity. Yeah, so we just write it down. Then to take out the range, we need to take out the h that I wrote here the formula. So h is equal as b is, well, this time it's the negative 8. No, the negative 8, sorry. The signs changes because as here in the formula says, it's negative times negative, it is a positive. So 8 divided by 2 multiplied by 1 because it is only 1 squared, x squared, sorry. So 8 divided by 2, and the answer is 4. Now we need to take out the k, and we basically write out the main function, but instead of the x, we write down a 4. So is 4 squared minus 8 times 4 minus 20. And yeah, 4 squared is 16 minus 8 times 4, it is negative 32. And we just passed to 20. Now we just add and all that, and it is negative 36. Yeah. And well, here we can also find one that we're going to put in the graphic, which is the one of B. And we write first 4 as the x-intercept, and then we write down to negative 2, 6 as the y-intercept. And here we write down is to negative 2, 6 and a infinite sign. Now we just need to take out the x-intercept and one y-intercept. To do this, I'm just gonna use a different page. So now the first the first step is the x-intercept, and we just run the main function down. X squared minus 8x minus 20. And now we we break it down. Is first we write x and then the signs, and well, here the numbers will be 10 and 2. Now we just need to pass the 2 to the other side, so it's x equals negative 2, and here will be x equals 10. So we got the 2 x-intercept, and now we just need to do the y-intercept. Here x will be 0. So y equals to 0 squared minus 8 times 0 minus 20. So 0 times 0 is 0 minus 0 because 8 times 0 is 0. And 20, so the y is equal to negative 20. So now we're just going to graphic this. So now I'm just going to graphic everything, and I'm going to put first the x. So yeah, x to negative 2, I'm going to put there. And then the x10. Then the y that is negative 20. And then this one, that dx is 4, and y is negative 36. That I think it's over here. So now we just put a line. And yeah, that's everything.
So we have the square root of x plus 5 as the expression from which we have to get the domain and range. We have to keep in mind that the expression, whatever it is, has to be greater than or equal to 0. So we see that x has to be greater than or equal to negative 0. This is what the domain looks like. Now, how do you write this as an interval? The left side of the interval is equal to negative 5, and we have to remember that in the interval notation a bracket means equal to, and a parenthesis means that it is not equal to. Now the right side just keeps going to the right forever, so we say it's positive infinity, and nothing can be equal to infinity, so we put a parenthesis. Range, it is easier to look at the graph of the function, so we have to look at the y values. This point right here is at negative 5, 0. So the range is equal to 0 and it goes up to positive infinity.
Okay, we're going to learn how to solve these problems. First, we need to know that when having this kind of operations, we can do anything about it or get the x. So, we're going to mark this as x equals 0. Therefore, it's going to be a 0 over here too. Now, in this kind of problems, we need to know that we can find x and the values of x. So, we're going to take the x2 plus 12x plus 27, and we're going to find numbers that can make up this expression. Those will be x, parentheses x, and obviously numbers that can help us find this equation will be plus 9 and plus 3. Therefore, when moving it, it will be x equals minus 9 and x equals minus 3. So it will be over here x equals minus 9 and x equals minus 3. So over here we open up parentheses and we add minus 9, comma, minus 3. And that's how you solve these problems. Next, we're going to see how to graph them. Learn how to graph these problems. First, we're going to graph this one. Since the x over here is equal to 0, and we can do anything about it, we need to put the line to mark the space over here. And now we'll just go like this on this side, in the positive side, and like this in the negative side. Now, the same goes for the other one, but since we have minus 9 over here and a minus 3, we need to draw the line in the minus 3 and the minus 9. Now we'll do the same thing as the other one, so it will be like this and like this. Now since we have a gap over here in the middle, we have to do or graph something like this.